There is a particular kind of silence that precedes something terrible. Not quiet. A warship is never quiet. But a quality of normalcy, of routine unbroken, of sensors reading nothing that requires action. A silence of absence rather than peace. USS Fitzgerald had been in that silence for 4 hours when the Taiwan Strait changed. It was April 9th, 2027. 23:14 local time. The destroyer was transiting southbound through the northern entrance of the strait, approximately 31 nautical miles west-southwest of Hsinchu on the Taiwan coast. The passage had been coordinated with 7th Fleet as part of a standing freedom of navigation schedule that both the United States and Taiwan's military had been running on a near-weekly basis for the better part of 2 years. The frequency was the point. Routine meant normal. Normal meant accepted. The People's Republic of China had protested every single transit through diplomatic channels. It had done nothing else. Until tonight. The strait at night is a different place than it appears on charts. Commercially, it is one of the busiest shipping lanes on the planet. Upward of 40% of global container traffic moves through it annually. On radar, it reads as a dense, shifting field of contacts. Bulk carriers, container ships, tankers, fishing vessels, Coast Guard cutters, and the occasional ferry crossing from the mainland to the Penghu Islands. The noise is constant. Classifying contacts, separating the routine from the threatening, is not a simple task, even in calm conditions. China's military planners knew this. They had been studying it for years. The drone swarm that left the eastern coast of Fujian province at 2241 was designed specifically for this environment. 40 Type 1500 maritime surface drones, each one approximately the size of a jet ski, low, flat, fast, and built from radar-absorbent composite material. The Type 1500 produces a radar cross-section comparable to a seabird. In the middle of a strait full of vessel traffic, it looks like nothing worth investigating. The swarm had been programmed to disperse immediately on launch, each unit taking a slightly different track, some mixing into the existing traffic patterns of commercial vessels already in the strait. Individually, they were invisible in the noise. Collectively, they were a weapon that had never been used in combat before. The Chinese military's logic was based on a calculation about saturation and simultaneity. USS Fitzgerald's close-in defense systems could engage perhaps 12 targets in a short engagement window, assuming optimal conditions. 40 coordinated simultaneous impacts were simply beyond the capacity of any single surface combatant to stop. The plan was not elegance, it was arithmetic. What the planners did not fully account for was the P-8A Poseidon maritime patrol aircraft operating 80 miles to the northeast. The aircraft had been conducting routine anti-submarine surveillance since 2000 hours. It was not, nominally, tasked with surface threat monitoring, but the P-8A's onboard radar system had been sweeping the strait as a secondary function, and at 22:53, 12 minutes after the drone launch, one of the aircraft's operators noticed something unusual in the contact picture. Not a single contact. A pattern. Small returns, barely there, dispersed across a wide area, all carrying roughly the same velocity vector. The operator flagged it. It took 11 minutes to build confidence in the assessment and pass it to USS Fitzgerald. 11 minutes of warning. In a different engagement, 11 minutes would have been enough. Tonight, it would be close. The warning reached Fitzgerald at 23:04. The officer of the deck had the ship at Modified Readiness Condition 3, standard for transit. General quarters was sounded at 23:05. The Combat Information Center was fully manned by 23:07. The Aegis combat system began tracking contacts at 23:08. What appeared on the tactical display was unlike anything the crew had trained for in simulations. Not a handful of missile tracks converging from a single bearing. A field. Dozens of small, low contacts distributed across a 22 nautical mile arc, closing from the northwest and west at speeds between 35 and 45 knots. The Aegis system, designed to classify and prioritize threats, was working at the edge of its software parameters. These contacts were not missiles. They were not aircraft. The system was classifying them as surface vessels and struggling with that classification because surface vessels do not behave this way. The tactical action officer made the assessment manually. This was a coordinated surface drone engagement. He had never run this drill outside of a classroom. He had thought about it many times. He had 37 contacts on screen, and 6 minutes before, the lead elements reached engagement range for the ship's defensive systems. The first line of defense would be the 5-inch deck gun, the Mark 45, capable of engaging surface targets at ranges up to 20 nautical miles with guided munitions, closer ranges with standard rounds. It was not designed for swarm suppression, but the longest-range precision system available. Fire control began engaging at 23:12 against the lead elements of the swarm. 3 confirmed neutralizations in the first 90 seconds. 2 rounds missed. The drones were fast and turning. The math was already unfavorable. The second line was the deck-mounted .50 caliber and 25mm remote weapon stations. 4 of them distributed around the ship's hull, each capable of engaging small, fast surface targets. They began engaging at 23:13. The operators were fighting with light amplification optics in a strait with ambient light from commercial shipping, a half moon, and the glow of Taiwan's west coast on the eastern horizon. Each weapon station could track 1 target at a time. 4 weapon stations, 34 remaining contacts. The Phalanx close-in weapon system, designed primarily for airborne threats but capable of surface engagement, was brought to surface mode at 23:13. It began engaging contacts at 800-meter range, working outward from the most immediate threats. The 20mm stream at 4,500 rounds per minute is effective against small, rigid targets. It is effective against 1 at a time. In 6 minutes of defensive engagement, the ship's systems neutralized 22 of the 40 drones. 18 remained when the first wave reached the hull. The impacts came within 9 seconds of each other. The Type 1500 carries a shaped charge warhead optimized for penetrating hull plating rather than detonating on surface contact. The design intent is to get the energy inside the ship rather than expending it on the exterior. The first impact struck the starboard side aft at the waterline, frame 178. The charge penetrated the hull plating and detonated inside the aft steering gear compartment. Flooding began immediately. Not gradual seepage, but pressure-driven inflow through a hole in the hull below the waterline. The second impact hit the superstructure on the port side, the communications and antenna farm mounted above the bridge. The charge tore through 3 antenna arrays and severed the primary satellite communications feed. The ship's link to 7th Fleet went to backup. The third impact, and the most consequential, struck the starboard side amidships at frame 122. the external housing for the SPY-1D radar array on the ship's starboard quarter. The array went dark. With it went 1/4 of the Aegis system's radar coverage and a significant fraction of its processing bandwidth. The remaining defensive systems were now trying to manage 15 still inbound contacts with degraded tracking. 4 more impacted the hull in the following seconds. 2 above the waterline, causing superstructure damage and fires in a berthing compartment and a damage control storage space. 2 below the waterline, adding flooding volume to the aft section. The ship took on a 4-degree list to starboard within 90 seconds of the first impact. Then the phalanx, operating now in autonomous mode against the remaining contacts at close range, completed its work. 7 more drones neutralized in the final 20 seconds. 4 reached the hull and impacted without detonating. Their warheads had been triggered by proximity sensors that malfunctioned at close range, possibly disrupted by the radar and electronic emissions environment of a ship at full combat power. The engagement was over. Of 40 Type 1500 drones, 11 had reached USS Fitzgerald and produced effective warhead detonations. 7 had reached the hull without detonating. 22 had been neutralized before impact. The cost of those 11 effective impacts was immediate and severe. The aft steering gear compartment was flooding. The SPY-1D starboard array was offline. Primary satellite communications were severed. 2 compartments in the superstructure were on fire. The ship was listing 4 degrees to starboard, and the list was increasing. The below-waterline breaches were adding flooding volume faster than the initial pump capacity could manage. 1 gas turbine generator had tripped offline due to a power fault caused by the communications impact. The ship was running on reduced electrical power at the same moment it needed every system it had. And somewhere to the northwest, 40 drones had just proven that China could do this. The damage control response that followed over the next 22 minutes was, by any objective measure, the difference between USS Fitzgerald returning to port and USS Fitzgerald going to the bottom of the Taiwan Strait. The most urgent problem was the flooding. 3 separate hull breaches below the waterline were introducing water into the aft section faster than any single response could address. The flooding boundary protocol, isolating compartments to limit the volume of water the ship must manage at any one time, was established within 4 minutes. The aft steering gear compartment was sealed. The flooding inside it was uncontrolled, but it was now contained. The ship would lose that compartment. It would not lose the next one. The portable submersible pumps, P100s, capable of moving 100 gallons per minute, were deployed to the 2 partially flooded aft engineering spaces that were still accessible. Each pump weighed roughly 90 pounds. Carrying them through the ship in the dark, with backup lighting only, past hatches that had been sealed in flooding boundary procedures, required navigating a different ship than the one the crew had left above decks. The routes changed. The landmarks changed. The weight didn't. The fires in the superstructure were managed with the aqueous film-forming foam system, AFFF, which suppresses fire by cutting off the oxygen supply to the burning material. The berthing compartment fire was extinguished in 7 minutes. The damage control storage fire took 11. The initial AFFF application was partially effective, and a secondary source of ignition kept reigniting until the source was physically located and separated. The team that found it did so in a smoke-filled space with 0 visibility. The person who found it did so by touch. The power restoration came from the engineering team, who brought the trip generator back online after isolating the fault that had caused the trip. It had gone offline because a power surge from the communications impact had propagated through an unprotected circuit. The fix was not elegant. It involved bypassing a protective system in a way that the operating manual explicitly cautioned against under normal conditions. These were not normal conditions. The generator came back up. The ship's power situation moved from critical to manageable. The SPY-1D starboard array remained offline. The flooding in the sealed aft compartment remained uncontrolled. The list stabilized at 6 degrees, not 0, but no longer increasing. 22 minutes after the first impact, the captain reported to 7th Fleet. The ship had been struck by an estimated 40 coordinated surface drones, Chinese origin, Type 1500 class. 11 effective warhead detonations, multiple additional hull impacts without detonation. 1 radar array offline. Primary satellite communications lost, backup operational. 1 compartment sealed with uncontrolled flooding. 2 fires extinguished. List stabilized at 6 degrees. Propulsion nominal on 3 of 4 turbines. The ship was degraded. It was operational. It was not going anywhere it didn't choose to go. The authorization for the response came 4 minutes after that. The target package had 3 categories. The first was the launch infrastructure on the Fujian coast. Chinese military analysts had long been transparent, in their own publications, about the concept of distributed maritime drone operations launched from prepared coastal sites. The sites themselves, hardened launch ramps, maintenance facilities, communications nodes, and the fuel and battery infrastructure that sustained drone operations, were not hidden. They were understood to be part of China's anti-access strategy. 3 primary drone launch facilities along the Fujian coast had been geographically fixed by U.S. intelligence for over a year. Tonight, 1 of them had been used. The second was the over-the-horizon radar network on Pingtan Island, the nearest large island on the Chinese side of the strait, whose radar installations had provided the targeting and tracking data that guided the swarm's approach to Fitzgerald's position. The third was the planned surface combatant, operating 44 nautical miles to the northwest of Fitzgerald's position, a Type 05 4A frigate that had been maintaining a position consistent with command relay functions for a coordinated operation. The response would be multi-domain, and it would begin in under 40 minutes. USS Changhoon, operating 180 miles to the northeast, fired the first salvo. 16 Tomahawk cruise missiles, launched in 2 sequential waves 8 minutes apart. Each Tomahawk costs $1.8 million. The 16 rounds represented $28.8 million in ordnance, launched in the first 6 minutes of the response. Their targets: the 3 drone launch facilities on the Fujian coast. Flight time at standard cruise, approximately 52 minutes. Running cost so far, $28.8 million in Tomahawks, plus the damage to USS Fitzgerald, which early estimates placed at $89 million in repairs. Total U.S. military cost of the engagement so far, approaching $120 million. The Type 1500 drones that had struck the ship cost an estimated $180,000 each. 40 of them represented $7.2 million in Chinese military expenditure. The exchange ratio, even before the response landed, was already instructive. Money shock. The 40 drones cost China $7.2 million. The response would cost the United States $134 million to execute. And it would cost China infrastructure assessed at over $2.3 billion. USS Lake Erie, operating as part of a surface action group 220 miles south, launched 8 Tomahawks against the Pingtan Island radar complex. These rounds were modified with a terminal targeting algorithm developed specifically for hardened radar infrastructure, designed to impact antenna arrays, processing buildings, and power distribution nodes in sequence to ensure that even a partial strike degraded the complex beyond immediate repair. The radar complex had been assessed as a key node, not just for the drone operation that night, but for China's broader over-the-horizon maritime surveillance network in the strait. Taking it offline was worth more than the cost of the 8 rounds. 8 more Tomahawks, $14.4 million. Running response total, $43.2 million. From USS Ronald Reagan's Carrier Air Wing, a 4-aircraft strike package, 2 FA-18F Super Hornets, and 2 EA-18G Growlers launched at high speed toward the strait. The Growlers went first, their electronic warfare systems designed to suppress the air defense radar network that China had deployed along the Fujian coast. Without radar, the ground-based air defense systems defending the drone launch sites would be operating blind. The Growlers could not be jammed back. The systems they carry are the most sophisticated airborne electronic warfare platforms in service. They arrived on station 12 minutes before the FA-18S and spent those 12 minutes methodically working through the radar network. When the F/A-18S arrived, the air defense picture was clear. The Super Hornets carried Slammer standoff missiles, fire-and-forget weapons that the aircraft can launch from outside the range of most ground-based air defense systems, and then turn away. The pilots never had to fly over the target. The missiles flew themselves in, using GPS guidance updated by an infrared seeker in the terminal phase. 2 rounds per aircraft, 4 aircraft, 8 Slammer strikes against the command and logistics infrastructure at the 2 primary drone launch sites. Combined ordnance value, approximately $16 million. The fires at the first facility began 23 minutes after the F/A-18S launched against the Type 054A frigate. The response was handled by 2 SM-6 missiles fired in surface-to-surface mode from USS Chunghoon at extended range. The SM-6 was designed as an air defense interceptor, but its active radar seeker works against surface targets as well, and at a range of 130 nautical miles, it gave Chunghoon the ability to engage the Chinese frigate without closing to within range of that ship's own weapons. The frigate detected the inbound rounds and attempted to engage with its own air defense system. One SM-6 was successfully intercepted. The second was not. The Type 054A's radar and communication systems were disabled. The ship was left adrift. 2 SM-6 missiles, $4.2 million. 1 Chinese frigate removed from the operational equation. The fog of war arrived in 2 forms, as it always does. The first, the Tomahawks targeting the 3rd drone launch facility, a site on the southern end of the Fujian coast, further from the strait than the other 2, found an empty installation. The facility had been evacuated 4 hours before the engagement. The drones and their launch vehicles had been dispersed to a secondary location 12 miles inland. The Tomahawks impacted the fixed infrastructure, buildings, ramps, power systems, and rendered it inoperable. But the mobile components of the facility, which represented perhaps 40% of its operational value, were not there. They survived. This was, in retrospect, not surprising. The Chinese military had spent years studying how the United States responds to these engagements. The dispersal of mobile assets before an operation that might invite retaliation was standard procedure. The fixed infrastructure was expendable. The mobile launchers were not. The second fog of war was more operationally significant. One of the slammer rounds targeting the command infrastructure at the first drone launch facility impacted the designated building at the correct coordinates. The building, according to subsequent intelligence assessment, had been converted from its military command function to a civilian logistics use 8 months earlier. The military command node had relocated. The building that was impacted was, by the time of the strike, a commercial warehousing facility. There was no record of personnel present at the time of impact. The damage was assessed as collateral. It was noted in the official record. That note would matter later in the diplomatic conversations that followed. But in the early hours of April 10, 2027, it was one line in a damage assessment that was still being compiled. When the accounting was completed, both sides had lost something. USS Fitzgerald had taken the most complex surface-to-surface drone engagement in the recorded history of naval warfare. She had been struck 11 times. She had not sunk. The crew's response to the flooding and the fires had kept her above the waterline when the engineering math suggested the margin was narrow. She would spend 11 months in dry dock and cost $89 million to restore to operational status. She returned to port under her own power, listing 6 degrees, with a sealed compartment and a dark radar array. But moving. That distinction, moving, was everything. On the Chinese side, 3 drone launch facilities were rendered non-operational. 2 would require extensive reconstruction. The third had been vacated before the strike and could theoretically resume operations from its dispersed components. But without its fixed infrastructure, doing so would take months of logistical effort. The Pingtan Island radar complex lost 40% of its antenna infrastructure and its primary processing facility. Its ability to provide over-the-horizon targeting data for Strait operations was assessed as significantly degraded for 6 to 12 months. The Type 054A frigate was towed to Xiamen Naval Base, where its repair timeline was assessed in years, not months. The 40 Type 1500 drones China had launched cost $7 million to manufacture and deliver to USS Fitzgerald. The response they triggered cost $134 million to execute. The infrastructure it removed had taken years and an estimated $2.3 billion to construct and position. That ratio is not about the money. The money is just the way of measuring something harder to quantify: the cost of miscalculation. China's military planners had designed the drone swarm operation around a specific assumption: that a proven capability demonstration, at scale, in a contested waterway, during a period of elevated political tension, would shift the strategic calculation in the Taiwan Strait in Beijing's favor. Show the Americans that their ships are vulnerable. Show Taiwan that its protector can be reached. Create doubt. What the operation created instead was a detailed and live-tested understanding of exactly where Chinese drone swarm doctrine succeeded and exactly where it failed. The 22 neutralizations before impact were documented. The 4 drones that reached the hull without detonating were recovered and examined. The specific failures in the Type 1500's proximity fuse under high electromagnetic conditions were catalogued. Within 72 hours of the engagement, the data was being used to improve the defensive systems of every American destroyer in the Western Pacific. China had paid $2.3 billion for that research. They had not intended to. and USS Fitzgerald had spent 11 months in dry dock, and one compartment in her aft section had been sealed with water in it, and a crew member who had been in the wrong place when the flooding boundary went up. Neither side announced that publicly. The strait between Taiwan and the mainland is 110 miles at its narrowest point. On the morning of April 10, 2027, both sides knew more about that distance than they had the night before. Whether that knowledge made it shorter or longer depended entirely on what each side chose to do with what it had learned. The United States chose to schedule the next Freedom of Navigation transit for April 23rd. The calculation had not changed.